So I'm going to do a little demonstration here. This is kind of a Murray family tradition. And you know, we would typically have glasses like this at a Murray family dinner. And I'm not even sure what we put in these glasses. I just happened to get them out of the cupboard and put water in them. You know, which I think that's what we drink out of them. Isn't that right, honey?
Yeah.
Okay, there we go. So it's important that you have glasses that are nice and thin. So they actually ring like that. Okay. And you also have to have very, very clean fingers. So clean your fingers off. They have to squeak on there. And if you do it just right, you can make them sing. And this is the resonant frequency of this glass. Now you can have a little fun, and this is of course where the musical talent of the family would come out. You can put water in the glasses, and if you put water in the glasses, you can change the tone. Here, come over here and show them what this looks like. Look at the crazy ripples. Get it right over the glass and look at that. Anyway, with some talent, you can actually play two glasses at once. So to give you some idea what's going on here, let's look at a slow motion video of, this is actually a violin string, okay? In a moment here, I'm gonna hit play, and this thing is going to, the bow is gonna start to move across the string here. And what's happening is it's the same thing with the bow and my finger, is that my finger is actually sticking on that glass. And here it's just starting. You can see the bow is moving like that, right? And if you watch where the bow contacts the string, okay, you can see that the bow actually catches the string, pulls it to the side, and then at some point the string breaks free and slips, and then it sticks and it slips and it sticks, and that is actually coordinated by the actual motion of the string. You can see the cursors right there. You can see the bow is moving. And of course, if you look at the string's motion is much more complicated than just a simple sine wave. So for sure, there's all kinds of overtones and harmonics that give the string its rich sound like that. This works only if the bow sticks to the string. And this is why you never want to touch a bow, because the oil will make it slip rather than stick. And that's why my fingers have to be so clean when I'm making the wine glass sing, because my finger has to squeak, it has to stick. Okay, so this is my latest toy. I just ordered this online during the pandemic, okay? Now, if I'm not mistaken, I would say that this is a Chinese spouting bowl that first appeared in the Han Dynasty, 202 BC to AD 9. 4 Han dragons can be seen in the bottom of the basin spraying streams of water. They're not spraying right now. Up the sides of the bowl. It is said that the bowl was a kind of plaything for nobles, gifted scholars, and socialites in the Ming Dynasty. It was believed to foster happiness, prolong life, and increase strength. Okay, so just a sec. I don't know if you can see the dragons in there. Do you see the dragons? There's a dragon right there, spouting water. And there's one there. There's one there. And the placement of those dragons is not accidental. Okay, so let's just see what this thing can do. This is pretty cool, isn't it? Look at the pattern there. Notice that the water's spouting up at those same 4 corners where the dragons were, right? So what this says is that the motion of a Chinese spouting bowl is much more complicated than a violin string. But what I want you to do is notice specifically, let's just do a freeze frame here. Notice that there are 4 places, these are antinodes, where it spouts up, and then there are 4 places where it doesn't. It's relatively quiet. Those are the nodes, right? So antinodes, watch this. The antinodes are where it's shooting way up, and the nodes are where it's not moving. So that means that this bowl is actually what those I'm just going to guess that those antinodes where it's moving a lot, they're moving toward each other, while the diagonally opposite ones are moving away, and then vice versa. I think that's the mode of resonance here, but we need better photography to tell that.